When we think of the sound of a synthesizer, we're probably thinking of something simple, an instrument built on top of a basic periodic waveform, an oscillator. Now you could generate all kinds of sounds from this one basic design, from simple waveforms like sines, triangles, saw, pulse, whatever, all the way up to more complex sounds like FM or wavetable synthesis. But today we're going to look at a completely different approach to synthesis, one that isn't based around any constant waveform at all, but instead on tiny microscopic particles of sound. We're going to be looking at granular synthesis, where we take an atomic approach to sound. So, what is granular synthesis? Well, the approach develops out of the work of physicist Denis Gabor in the 1940s, and it examines the audio signal as a series of small grains of sound. So a grain being something of approximately less than 50 milliseconds. Now, according to Tom Holmes, in contrast to Fourier's analysis of sound, Gabor looked at developing, to quote, a mathematical principle for representing sound as being composed of minute grains, each with its own waveform, envelope, duration, density, and position in space, end quote. Now today we're going to be looking at this approach from the perspective of electronic music, but it's instrumental composer Yannis Xenakis who's generally considered to be the kind of pioneer of developing a compositional approach to working with grains of sound. Here stochastically composing with tiny percussive sounds of orchestral instruments. And then over in the electronic music kind of realm, Curtis Rhodes is the figure who developed one of the earliest approaches to translating Gabor's theories into a practical programming environment for creating electronic music. Now, Rhodes is a really important figure here whenever we talk about granular synthesis. I mean, he literally wrote the book on granular synthesis, which is called Microsound. And a lot of what we talk about today is kind of going to lift out of that. Now, granular synthesis, at its most basic, uses many small fragments of sounds, and we're calling these grains. And we're going to piece together a complex stream of these grains. So rather than any constant waveform like a regular oscillator, it's easier to think of this as a stream of many sounds. So many sounds rather than just one sound. And each of these grains, each of these sounds, has its potential for having its own unique character. So from there, we can control these grains in different ways. We can allow them to develop or shift. We can synthesize sounds that just wouldn't be possible with any kind of regular oscillator. So think about each grain could have its own sound, its own pitch, its own timbre, duration, even its position in the stereo field. Before we get ahead of ourselves, let's start with that fundamental element. What is a grain? Well, a grain is a short waveform, the grain's content, shaped by an amplitude envelope. There's two parts there, the waveform and the envelope. Now, in granular synthesis, we can use a variety of envelopes. We can use anything from a simple envelope, attack, sustain, release, up to things like Gaussian curves, which we'll look at today. The grain's duration can be constant, random, or dependent on frequency. So shorter grain durations for higher frequency sounds, longer durations for lower frequency sounds, something like that. It could be really short, giving very little indication of the grain's content, so something short and percussive, like an impulse or a click. Or something a bit longer, so that we can really hear more of that grain's content, more of that waveform. Now, the waveform within the grain, the sound content, could be either synthetic, so something synthesized like a bunch of sine waves, or something sampled. Today, we're going to look at building a granular sampling synthesizer, a synthesizer that plays grains of sampled sounds from an audio file. So how's that instrument going to look? Well, we're going to start with a sound file. We'll have something loaded into a buffer. Now, you could use a live signal kind of constantly recording into a live buffer, but for ease of use, we're just going to work with a pre-recorded sample, preloaded sample. And from that buffer, so we've got a buffer here, we're going to pull out individual tiny grains. And they'll be triggered back as kind of these little isolated envelopes. So to play multiple grains, so overlapping grains, we're going to have to use some polyphony. So we'll use the poly object in Max. Now, what I would say is that if you have not used Max before, or you haven't used it in a little while, don't worry, we're going to patch along together. So hopefully it should be fine. But just to kind of a brief note there, because this is a kind of unfamiliar approach for a lot of people to synthesis, it might seem like we're working kind of ass backwards in some instances. We're going to be starting by building the envelope before we've built the content and things like that. So just bear with us and it will kind of come to pass. So where do we start? First things first, we need to make our buffer and our grain generator in Max. Now the grain generator is the heart of the whole operation, really. It's easy to get kind of caught up in, you know, how clouds swarm around us and, you know, all of the strange and complex behavior of things. But really the grain generator is the star of the show here. And it doesn't matter if we're dealing with a single grain or an entire cloud of grains. The grain generator is fundamentally always going to be the same. It's an amplitude envelope, and that's going to be applied to a waveform. So a grain generator also gives you control of individual parameters of each grain. So amplitude, duration, frequency, panning, all sorts of things. This is a simple grain generator that we're going to be working with, and it's given in Curtis Rhodes' book, Microsound. So at the top of this image, we have an envelope generator, and that's going to be used to shape the oscillator or waveform. Note the pitch control here, and that will be sent out to the output. So we're going to follow this design broadly and start building our envelope. So I've talked about creating ADSR envelopes in earlier videos, and if you want, you could do what we're about to do with an ADSR, or you could explore using Max's function objects to make a nice kind of breakpoint line chart. But today I'm going to look at building a Gaussian envelope, and that will give us a nice smooth bell-shaped curve, okay, fading in and then fading back out. Now, because our grain is going to have a variable duration, we can change how long each grain is. We need a really efficient way of applying a scalable envelope. So our envelope can change for each grain. Now, an ADSR or a function line could do this, fine. But what I'm going to do today is I'm going to actually use a buffer to make this. Now, if you don't understand exactly what I'm doing, or perhaps why I'm doing it, particularly the kind of nitty-gritty of a lot of the maths, don't worry too much. What I would suggest is you try and patch along with me here, because a lot of this process is going to be about you kind of exploring and experimenting with stuff and kind of learning as we go. So a lot of this might not make sense initially, but as it falls into the larger instrument, I really hope that it will kind of all start to make sense with you. Now, I've got a new Max object here. Now, eventually this is going to end up as a sub patch of a much larger instrument, but we don't need to worry about that for the time being. We're just going to focus on making this nice little envelope generator. And what we need is, whenever this instrument first loads, it needs to initialize our envelope. It needs to make our envelope straight away. So I'm going to do that with a load bang message. And what that's going to do is that's going to send a bang when this patch is first loaded. And that is going to be attached to what we call an Uzi object. Now, Uzi is going to rattle off, when it receives a bang, a list of 512 numbers, so from its current index. So I wonder if all of a sudden, when I click that, when I initialize this, it's going to rattle off from 0 to 512. Now, what we're actually going to do is we're going to pass this through an expression. And what that's going to do is that's going to scale those digits from 0 to 512 to give us a kind of Gaussian window. Now, the maths of this expression look horrendous. I'm not going to bother reading it out to you. What I will do is I will post this line in the comments of the video, so you can just copy and paste this in, because that's what we're going to be working with right now. Don't worry too much about how and why you kind of get this value at the moment. You'll see what it does in a second. Now, what's going to happen here is this is going to run through and it's going to give us a list of values that create this nice bell-shaped curve. But what we want to do is we're going to pack them together. So I need to pack into a 0, so that's an integer, and a 0 decimal, so that's a decimal number. So what we get is on the right inlet here, we get this floating number, and on the left inlet, we get the index, the value 0 to 512. And we're going to pack this all into a buffer, and we're going to use the peak object to do this. Now, I appreciate that if you're watching this, you're probably thinking, what the hell is a peak object? Where did he find Uzi? What's expr 0.5? I've been doing this for a few years, so I kind of know what some of these objects are. Don't worry if you don't know about them yet. As we start to use them, you'll figure out why we're doing it and what they do. Now, peak is a really lovely object, and all it's going to allow us to do is record into a buffer sample by sample. So it effectively, imagine stepping through each sample of a buffer of audio and saying, okay, step 1, that's going to have a value of this. Step 2, that's going to have a value of this. And we're just sort of punching in a buffer sample by sample. I'm going to come back to the #0 in just a second. But effectively what this is going to do, when I initialize the patch, it's going to rattle off numbers from 0 to 512. That is going to form the index, so where in the buffer. And then it's also going to run through this expression, which will give us that Gaussian curve. We also need a buffer object. That would help. So I'm going to call this #0 grain env. And I'm going to specify that it is 512 samples long. There we go. So we've got our buffer. Actually, I'll tell you what I could do. This would make it nicer. I'm going to give this p window. Wait, no, waveform. Sorry. Buffer name #0 grain env. With a little luck, that will give us our waveform. So, fingers crossed here. Hey, there we go. So you can see now, this kind of gives us a nice helpful thing. You can see each of those 512 steps, not quite, but you can imagine 512 steps. Each one of them has a Gaussian kind of curve value there. So there's our nice envelope curve. It's recorded into a buffer, so handily we can kind of call this wherever we need it. And all we're going to do to use this is kind of play through that buffer at a speed that we need. And that's going to give us that nice kind of curve. If you can imagine like amplifying this against a signal, it'll give us that nice smooth in and out. Now, I just want to talk very briefly about this #0 thing. In Max, this is a symbol for creating a unique identifier. So in an argument, you can use that #0 symbol to give you a kind of unique ID for whatever patcher or sub-patcher you're in. Now, I'm just doing it now because it'll save me time later. You'll understand why we're doing it later on. Basically, when we start to look at kind of polyphonically generating grains, each one of those grains needs to have its own unique ID, right? Otherwise, the volume would just be set for all grains, and you might be using thousands of them. So instead, by using #0, each time a grain is generated, that's going to be represented as a unique number. I think it's like 4 or 6 digits, unique digits each time. So it might look a little bit strange now, but it's a lifesaver later on. And just so I don't forget it, if anyone is doing this with Max for Live, Ableton uses a slightly different syntax. So instead of #0, I believe it's 3 hyphens, but maybe check that. Okay, moving on. Now, At this point, we could just create a really simple sine wave and multiply that sine wave by our envelope. And that would give us a nice kind of synthesized grain waveform, okay? We would just have a short kind of curve in, but we're going for something a little bit more ambitious here. We're wanting to build a sampling granular synthesizer. So to do that, we're going to need an audiophile kind of buffer. Now, what I want to do, I'm just going to encapsulate this. So I'm going to copy everything, and I'm going to hold Command, Shift, and E on Mac. And that's just going to drop all of this into a little subpatcher. So if I wanted that, I could open it back up, and sure enough, we've got our little subpatcher. But for the time being, I can just bob this over into a corner down here. So if we think back to the grain generator, we've currently got one of the two components. We've got the envelope. What we haven't got is the content. We haven't got the waveform yet. So we need that. We need our buffer. So first of all, let's create our buffer. And this one's going to be our kind of main sample buffer. So I'm going to call this #0 using that again. I'm just going to call this grain buffer. There we go. And I can create, as I just did, a waveform, give it the buffer name, #0 grain buffer, and then I can load in an audio file. So I've loaded the 21st Century Masterpiece Pony by Genuine as our kind of test material here. So this is going to make up the content of each grain. So we're building the grain generator now. So the way that this is going to work is we've got our waveform on the one hand, and we've got the envelope that's going to be used to shape that waveform. What we're going to do to make that is we're going to use the wave object. And essentially what that allows us to do is to read through a buffer by index. So in the same way that we used the peak object before to kind of specify the value of each step on that Gaussian curve, now what we're going to do, we're going to use the wave object to kind of read out of that buffer step by step. So if I put in the same, was it grain env was the name of our, and now what I can do is I can use the line object, which we've used in the past, to kind of step through. Now what I'm going to do is, just for kind of sake of argument, I'm going to set it to 512, so it's going to step through each number from 0 to 512. Line. And that will feed in here. Now, let's just very quickly, if I build a little scope here, hold on, I'll just make this window a little bigger here, and I'm going to set this to automatic. So it should be, if I step through, if I trigger this line, we'll read through the envelope. So just to remind you, read through that shape over time. So let's have a very quick kind of audio test of this. You don't have to patch along. What I'm going to do is I can copy it in. So here I've just copied in the groove object, which just plays back from our buffer in a constant loop at a given speed. So what I'm going to do is, this is just going to play back constantly. And what we'll do is we'll apply this envelope to the output. So we'll use that when I trigger the envelope, it will use that to shape our kind of curve. So there we go. Now this is very, very quick. It's just 512 kind of milliseconds or So it's stepping through that buffer. We could set this a bit longer if you wanted to just kind of check what's going on. We could set this to maybe a second, 1,000 milliseconds. And we'll hear that grain content. Now, in granular synthesis, we're actually going to be working with much, much shorter durations. We're going to be working with things from 50 to 100 or something like that, say. So we'd be working with very short, very quick envelopes. Notice how we don't hear any, kind of recognizable sounds. We kind of get little hints of the kind of timbre, and it's much more subtle. Now, what we actually want is not this. We rather want the waveform to be played back at specific kind of points. So we want to specify where our sample starts and where it ends from the main audio file. So what we're going to do is we're not going to use Groove to just play a constant stream of sounds. We're going to specify which elements of our audio file we want to play. So we're going to use the play object to play back specific elements of our audio file. And then we're going to use the wave object to shape the amplitude envelope of that. So let's create play, and we're going to call again the kind of sample. So in this case, Genuine's Pony. I probably could have given this a better name, like #0 sample or something, instead of grain buffer. But it is what it is. If you want to change yours, maybe do it now. Now, all I'm going to do, let me line them up so that it makes sense, is I'm going to use the same kind of argument that I was using for the amplitude envelope. I'm going to use this line object to kind of scan through that audio buffer and play back that. Now, we want to do this at the same time. So what I'm going to do is I'm just going to use a button or a bang here to trigger these at the same time. So when I click this button, what we should get is playing back through our sample, and at the same time playing back through our amplitude envelope, and then applying those, multiplying them here to kind of give shape to the grain. Now, there's going to be a problem though. That problem is that I was just doing this from a very kind of short, tiny section. So if you think back to how line works, we've looked at that in previous videos, but if not, just hold Alt on the object and it will bring up the help file up here. And if I look at this list input, you'll see that the way that this works is we're going from a value 0 to a value 1 over a period of time, in this case 2000. So what we're saying here is go from 0, sample 0, to sample 1 over 50 milliseconds. Now, from 0 to 1 is kind of useless for our audio sample. So maybe we would be go from 0 to 1,000 over 50 milliseconds. Then we should hear something. Ah. Okay, maybe let's make it a bit longer just so we can hear. Let's take it back to 512 as our duration. Now, because we're saying play from the start of this sample, sample 0, to 1,000 samples in, and do it all in 512 milliseconds, everything is being squashed up. So it's being played too fast. It's not being played at a kind of realistic speed or a normal speed. So if we're going to start, and similarly, if we wanted to say, okay, well, we don't want to play from the start, we want to play 100 milliseconds in. In fact, actually, as a kind of example, let's say 500 milliseconds, because we're now playing, instead of from 0 to 1,000 to 500 to 1,000, we should be half the speed. So we need to think about some various kind of parameters that we want to control in our grain generator. We need to think about where we're going to play from in our audio sample and where we're going to play to, and how long that's going to take. So we need to think about kind of stretching the sound. So what we need to do is a little bit of kind of argument juggling at this point. And to do that, I'm going to use the pack object, and I'm also going to use the dollar argument. And basically dollar, so here, for instance, let's do this as $1. What that's basically saying is if you take this value as being whatever that number is. So if this was here, if this was set to 512, it's going to play over 512 milliseconds. If it was set to 1000 or longer, we end up with a longer amplitude envelope. Okay, so that dollar argument is going to allow us to pass variables through. So we're going to use that quite a bit. So I've had a little think about the parameters that I need to be able to control in my grain generator. Now for every grain, I need to be able to control the start point from that sample, from the sample buffer. So in this case, Genuine's pony. I need to control where we're going to start, how long the grain is going to be, and what the grain's pitch is. So let's make those. So I'm just going to create an integer number here. I'm going to create another integer, and then my interval ratio is going to be a decimal floating number. Now, let me just tidy this up. I'm going to get rid of this now. The wave and the envelope, I'll keep those together, but I'm just going to move those down here. I can get rid of this for the time being. And this. I'm going to move these just out of the way. I'm just going to give us a bit of space, because what we're going to have to do is a little bit of, like I said, juggling, just kind of making sure that some numbers don't go bigger than others and some are less than others and things like that. Now, as I said, we're going to pack these objects up. And what we're going to need here is we're going to need 3 values. Okay. And they're all going to go into this argument here. So this is going to need to be $1, $2, and $3. So what that essentially is going to be doing is telling the line object that we're going to take from here. So that's that first inlet of the pack object to the second variable over the time of this one. So let's say that our grain duration is going to be going here. And we know our start duration is going to be here. So what else do we need? We need our playback. Well, where does that go? Okay, so the interval ratio is actually going to be multiplying the duration by the speed that we want. So I'm going to take multiply 1 decimal. Remember to put the decimals in because otherwise it will kind of just turn this into a integer number. So that's going to go from our duration. We're going to multiply it by our interval ratio, and then we're going to use that to offset from our starting sample. So something like that. Now, so we'll put that there. Now what I'm going to do is I'm just going to give us some numbers here just so we can kind of monitor the situation. So that's going to just check what that is. There. Now, if this was something a bit more helpful than a negative number, let's say we're going to start from 1022, we want to play it for 500 milliseconds, and we want to play it at a regular speed of 1. Now, because this has all been, I've set these in different orders, they're not being triggered neatly, which is kind of a pain. So what I want to do is I want to make sure that these are all banged at the same time. that duration also needs to be set down here. There we go. Okay, so what we can do is we can now play back a single grain from a given point, so it could be over here, to a given duration, so in this case 500, at a given rate. Now, let's just check this. Let's just play around. So I'm just going to create a really simple metro object. It's just going to trigger every, let's say every half second. This is kind of a good way of just making sure that you're kind of triggering constant grains, and you can kind of play around with checking them. There we go. Okay, so don't need this anymore. So I can start playing around with our start point, playing around with our duration. But there's something interesting happening here. Because I'm triggering a new grain every half second, if I set it to longer, it's going to get cut off. So if I have it, I have to be careful about that when we have a kind of single train of grains here. But if I have very short grain, and then I can also change the pitch, or the rate at which I'm playing back each of these grains. So it seems like we have a kind of very basic kind of mono single train line grain generator now. I'm generating a series of grains, and I'm able to control where in our audio sample they play back from, how long they last, and their pitch. Another nice thing that we could play around with, at the moment we've just got mono grains, but wouldn't it be cool if we could use some stereo panning? So all I'm going to do here is I'm going to just take a very simple, the pan2 object. I'm just going to stick this in down here. And now we can use this inlet here, so MIDI panning. So this is just an integer from 0, which is left, to 127, which is right. And then we could start to pan things around, or even I could use the dial object and set, oh, it's already there. So what I could do, let me just turn back this. Now, that's kind of nice because I can make these kind of spatial sort of drifts of sound, which could be interesting. But what I want to think about, and this is where the real power of granular synthesis comes in, is what if every single grain had a different spatial location, okay? So that's really simple to do. All we'd have to say is every time we generate a grain, so in our train, that's every time we bang a grain, I just want to generate a random number between 0 and 128, or 127. And what that'll do is, every time a new grain is generated, it's going to have a different position in the stereo image. Let's have a listen. Now already that's way more interesting. It's really dynamic, and when we start to look at overlapping grains, you know, hundreds and thousands of grains, this can be a really beautiful sensation, particularly if you're listening on headphones. But what I would say is, well, why stop there? Why does it just have to be the stereo image? What if we started to play around with generating different starting points, or different durations, or even different pitches? And we can take the same very, very basic sort of system here, just generating a random number each time a grain is generated to specify a new start point, duration, or pitch. One thing we have to be careful of, though, is defining our boundaries. Now, for instance, I know, because I've used this little info buffer object up here, I know that my sample of Genuine's pony is this long in milliseconds. Now, the reason that I've added that info object to find that out is because if I start generating random start points or random durations, I need to be sure that I'm not going to specify an impossible starting point. I can't start my grain right, past the end of the sample. So I need to be able to define kind of limits there. And what we need to do then is to start to be very careful about what random numbers we generate and how far they go and where they go. Similarly, some of them are not problems of, is this impossible? Some of it is about tuning it so it works for you. Maybe just having a bunch of random pitches is just going to sound absolutely awful. But if we started to have random pitches that were all tuned to an octave, so changing our interval ratio from 1 to 2 to 4 or 0.5, having it tuned in maybe harmonic series or something like that could be really, really beautiful. Or just having tiny fluctuations, 0.001 shifting and having kind of this nice kind of dynamic fluctuation of pitch. At the moment, my patch is a bit of a mess. So what I'm going to do is I'm going to clean this up a little bit. I might encapsulate a few things, and then we can look at some simple and effective ways of setting boundaries on our random generators. Okay, so I've cleaned things up a little bit. I've tried to space things out a little bit more. So you'll see that I've got the waveform of our sample up here. I've got the amplitude envelope down here, and then I've labeled up the parameters that we're currently using. So as just a reminder, this is the sound that we've got. So that is starting 2000 milliseconds into our sample. The grain duration is 100 milliseconds, and the grain rate, the sort of playback speed, is 1. And I'm just randomly generating stereo sort of positioning. Now, I thought a nice thing to play around with and just to move around is that grain start position. Now, what if instead of just playing the same point each time, always 100 milliseconds, what if we just sort of nudged it around a little bit? So to do that, what I'm going to do is I'm going to specify a two locations. I'm going to specify a possible start point and a possible end point. Okay, so in the current example, this would be starting, say, at well, let's start at 100 milliseconds in, and let's possibly move it 100 milliseconds on. So let's say it could go up to 200. Now, what I'm going to do here is I'm going to create a random number every time we generate a new grain, as we did with the stereo positioning. And I'm going to offset it by our start point. That basically means every time I'm just going to add this number. So I'll put that down here. So that's going to go into the right inlet of this value. And then I'll just connect these up. So every time I'm going to ping that number and that number. So what we're currently saying is I'm going to generate a random number. I'm going to offset it by, at the moment, 100. Now, what is that random number? What's the limits there? Well, we don't want to say 200, because then that would actually give us 200 plus 100, which would say 300. So what we're going to do is we're going to subtract our start maximum. That's going to go into the left inlet from our minimum. So that's going to go into the right inlet. Note that they're switched here because you're saying it's 200 minus 100 rather than 100 minus 200. And that's going to give us, hopefully, 100. We'll take that off as our random number. Now, all being well, this should start generating random numbers between 100 and 200. Now, let me just move this up here. So what I'm going to do is I'm going to get rid of this. I'm going to connect up. I'll start it playing back for us, and then I'll connect this up, and you can hear the difference. Ooh. So that's a static starting point. And actually, let's just, so we're using the same place. Let's say we'll start at 2000, and we'll go up to 2100. So we get some unpredictability coming here. We could really, make this a lot more subtle, but we could take this down. So there's just a 45 millisecond margin here that we can just move sounds around. And we start to end up with something that has a little bit more kind of development to it. It feels like there's more fluctuation. There's something interesting happening here. It's a little bit unpredictable. It's quite nice. Now, you could very easily, from this point, play around with this mechanism of instead of defining a low point and a high point, you could, for instance, say, okay, I'm going to define a central point and give me a width. So you could say, all right, let's start 2000 milliseconds and play 10 milliseconds above or 10 milliseconds below and generate a random number between those two. We could do the same thing for our grain duration. So each grain, in fact, actually, let's try that. Let's just encapsulate. I can get rid of this and put that there. I can just encapsulate this to keep it clean. And let's just try this for each of the values. So I'm going to get rid of those. That and that. Okay, and we'll just keep the grain rate the same. So instead, I can now play around with my grain duration. So let's say that could go from 100 to 150. Let's see what we end up with here. What have I done wrong? I haven't triggered it. There we go. And now we've just got something that we can play around with a little bit more. We can make much shorter, we can make it a much wider choice. Similarly, we could do the same thing with our start positions. So while it might sound a bit more chaotic, we've got a real wide margin of possibility here. These could be samples playing from anywhere within that whole sample. Remember up here in the top right, we've got our total length. Or it could be playing from a very, very short duration to a very long duration. And we've really got a lot of scope to play around with here. Now, for the time being, this is going to sort us for a single line kind of grain train. So we can only play a single grain at any one time. And that's kind of, limited really. It's effectively like kind of just playing or triggering a series of very short samples. Where granular synthesis really begins to kind of come into its own is when we start building layers and we can work with kind of polyphonic layers of these samples. So in the next video, we're going to look at taking our very basic grain generator that we've made today and making it so that we're able to trigger hundreds, if not thousands, of these grains that all overlap and form these really kind of luscious clouds of grains. And we'll start to play around with other ways of controlling them and kind of making them a little bit more interesting. Okay, see you next time.